Now I would like to look at how we classify compounds and name them. Don't write any of this down. I want to read over it. Maybe jot down a few important points. The system here for naming an ionic compound, it's different from naming a covalent compound. Before we name it, you have to know whether it's an ionic or a covalent compound. So how are we going to determine that? We've practiced a lot in the past. You need to classify the compound as basically ionic or covalent. Basically, you're asking yourself, is there a metal or a polyatomic present? If yes, then we're going to consider it an ionic compound. If it's no, then you're going to name it using the rules of covalent compounds. This video only talks about ionic compounds. So again, we need to make sure we have a good understanding of this charge, just like we looked at with the crossover method in naming ionic compounds. Let's get some basic rules down here. Jot these down in your notes. Pause the video and write them down. You need to know what a monatomic ion is. You need to refresh your cat ions. Remember, cats purr, they're positive. Write the name of the element followed by a cat ion or cation for a cation naming. In the case of transition metals, we're going to look at the stock nomenclature, and we're going to take a look at that here in a second. One quick mention there is that most of our cations are going to be a little smaller here because they've lost electrons than their other typical elements. And then if we're looking at an anion in our example here, anions, they tend to be a little bit larger than the element itself because they're gaining electrons. For anions, naming them, it's a little different. You're going to take the name of the element, drop the ending, and add IDE. That's an important thing you need to know. IDE goes with anions, or negative ions, to the root word and then write anion. We're going to practice these a lot on the next two slides. Very briefly, talk about this stock nomenclature. Basically what it is, write this down. We're using Roman numerals to represent the ion's charge for elements, and we're basically dealing here with our D block elements, the transition metals. So on our periodic table here, you're looking at these guys right in this section. Remember, groups 3 to 12, transition metals. Real quick example here, iron. If you look on your periodic table, and we've mentioned this before, it's hard to see on this, but right here on this little section there are +2, +3 charges. Those are the possible charges that iron could form. Now, iron +3 is going to be written as iron Roman numeral 3. Compare that to an iron +2, we're going to look at an iron with a Roman numeral of a 2 in comparison. So that is the stock nomenclature using Roman numerals. Let's go ahead here and look at some examples of these monatomic, remember mono meaning one, ions. Fluorine becomes a fluoride anion. It's a -1 charge. I drop the INE and I add IDE to the end because it's an anion. Sodium, that's over in group 1, so it's going to be a +1 charge. You just write sodium cation. Again, the cation being a little smaller than the typical elements. Other examples here. Chlorine, it's another negative ion, an anion, so I'm going to drop the INE and I add IDE to the end. Calcium, positive +2 cation. I just write calcium cation. Pretty straightforward. Let's dive into some examples here. Practice with these monatomic ions. So let's go ahead here and take a look for lithium. Lithium is going to be Li. And again, if you're not sure what lithium's charge is, you can jump to the periodic table, find lithium right here, group 1, +1 charge. So it's going to be lithium with a little plus sign. barium. Again, barium. Not sure exactly what barium's charge is, so I'm going to jump to my periodic table here, find barium on the periodic table. It's right down here. Look up, +2. It's a +2 charge. And it's pretty much straightforward for all of these. Real quick, if we look here at our iron +2 versus +3, again, the Roman numeral here, because that's the stock nomenclature, tells you it's a +2 charge versus an iron with a +3 charge, or tin, Roman numeral 4 +4. It's always plus. We only use this on our metal transition metal cations. If we flop sides here and look at naming, how am I going to write the name of this? Well, CS you should know as cesium. So I'm just going to write cesium, and it's a cation, so I write cation after it. Let's look at iodine here. It's typically iodine, spelled like that. Now, when we are naming iodine, we drop the ending, drop the INE, and we add IDE, and it becomes iodide, and it's an anion. So it's basically pretty straightforward there on the naming for monatomic ions. And if you want here, you can take a look at all of the answers here if you would like to see those as well. If you practice these out yourself, you can check out those are the answers. Let's move on now to binary ion compounds. We're going to take two separate ions now and stick them together. They're going to form a compound, and we need to know how to name those. So basically, all that requires from us is to write the name of the cation first, followed by the anion. Remember, anions, you drop the ending and add IDE. Here's our examples. Ag and fluorine. Silver fluoride. I drop the INE on fluorine and it becomes fluoride. Calcium chloride for CaCl2. And again, I figure out that it's CaCl2 because I know, looking at a periodic table, that calcium has a +2 charge, chlorine has a -1 charge. I need two chlorines, two negatives, to balance the +2 charge on my calcium. So that's where that crossover method comes into play. The 2 goes right down here, the 1 goes right there. So let's go ahead and dive into some examples here of naming these binary compounds. Our first example here, Sr and O, strontium and oxygen. Again, if I'm not exactly sure on strontium's charge, I can look and see on the periodic table. I know strontium is going to be a +2, oxygen is a -2, so it's a balanced compound. And I'm just going to write strontium because that's the cation. You do not change the cation, it always goes first. And then oxide because I drop the oxygen's ending and it becomes IDE, oxide. Let's try this one here. Sodium, because that's my metal cation, iodide. I drop the INE on iodine and I add IDE. Flop sides here. Take a formula and go from a formula to the name. Well, Ba, that's going to be barium. So I will put in there barium. And then F2 is going to be fluorine. So it becomes fluoride. Calcium and oxygen, more practice here, is going to be calcium oxide. So what you can do is pause the video, try these examples here on your own. There's the rest of the answers here if you'd like to see those. And we'll keep moving on.